Probably when we are not speaking, we can switch off our mic so that we don't have any background voice. Okay, Vanshika? Okay. Yeah, here we go. So we are live and hello everyone. Welcome again. If you are seeing the second session, and I've already watched the first lecture. If you haven't watched the first lecture, so you can watch it because this is in continuation with the first lecture. The video is available in the live tab or in the group description too. And yeah, I'm also seeing the live chat. So hello, Anshika. Thank you so much for joining, and thank you so much for showing so much excitement. And we'll be having Suvendu sir in a couple of minutes so that we can continue all the concepts that we were discussing uh, in the last session. So hello, sir.
Hello. Hi, Mani.
Okay, so sir, I would like to introduce yourself with Vanshika. She will be the host, and I will be the co-host this time.
Okay, no problem. Hi,
Yes,
Vansiya.
nice to meet you.
Wonderful. So, sir, as we'll try to complete all the concepts maybe really quick, and if we have some questions, then we can also cover it. And I'll make sure that this live stream would not stretch too long. And I'll keep in mind the timing, and we'll try to wrap it up in 40 to 45 minutes, making it really practical and yeah, valuable too for the audience. And thank you so much, lovely people who are watching it live and maybe watch the recording in near future. So those who are watching this session for the first time and haven't watched the previous lecture, I would like to introduce you to Mr. Suindu Mohante. He is a senior AML engineer at Amazon. And yeah, definitely. In the last lecture, we have covered a lot of concepts. So I would like to encourage you to watch the recording and then afterwards you can watch the session. So without further ado, so in the stage is all yours, and we can carry forward or move forward with the remaining concepts or which you think that will help the students regarding the like important topics that we can discuss in this live stream really quick, not going too deep, but yes, by touching the complex concepts so that we can explain them in easy way, and then we can cover the questions if we have any at the end.
Sure.
How's it sounds?
Sounds good. Sounds good.
Sounds
Cool.
good. Amazing.
Uh, well, hey, so quickly I'll just, introduce myself and who have already attended the last session. You know me. I've given very detail about my introduction, but I'll give a quick introduction about me. I am Subendu. I'm based out from uh, U.S. Arlington, Virginia, and working for Amazon. And I do have almost 14 years of industry experience, and especially in machine learning, I'm working for almost 10 years. And here I'm working on the your Amazon device org on specific area of machine learning, LLM, and GPU optimization space, basically. So let's on the further due, let's talk about the last call I talked about more on what's the exactly your machine learning life cycle should be. You would expect part of a real uh, real life situation, or when you will be start working on a project, what exactly you should expect. And today today I'll go a little deeper in terms of picking up one of project, you can say. So which I cannot unfortunately I can share any of my working project. So I have picked up something kind of a dummy project, which will be relatively complex, like a real life. situation where you will be facing how exactly you should navigate a machine learning problem, how should you should read through it, and you should basically do the feature engineering, and how basically you can plan from a uh, basic implementation to a deep learning or the advanced implementation, basically, right? So let me share my screen and I'll talk about the problem statement first. Then I'll talk about the simple solution first. Then we'll be talk on top of that. We'll talk about how we can enhance that feature engineering or ML, model implementation that we can do, advanced algorithms that we can implement to enhance the accuracy and enhance the process. So with further ado, let me share my screen. Uh, just allow me a minute. Uh, just a minute. Okay, I believe I can't. Okay, okay. I'm trying to share my screen. Okay, let me know if you can see me. Just give a thumbs up. Can you see my screen?
Yes, sir, it's visible.
Okay, awesome, great. Cool. So this is basically a I'll be explaining a very uh, easier way. So like think about in a practical solution, right? So you must be going on a car, in any of the the modern car I'm talking about, which having the entertainment systems and on the when you will be interacting with the car entertainment system. So you have some assistants on the car, right? So you talk as a user, you usually talk about, hey, can you show me this restaurant, or what's the please navigate to this place, right? So you interact with the car system, or play this music, or what's the time now, or change the settings, so on, right? So think about mostly whenever you interact with the car, you give a voice command, and those voice command is basically is converted as a voice to text. Although that is not our scope, let's think about uh, you interact, and you given a voice, and that is converted as a text, and in your car, uh, you do have a model inbuilt, which is basically pick up the your text that you have given the command, and it understands the command, and and find out the intent out of it. When you say that, the intent out of it is basically, the intent is basically, think about, um, you can be basically control the navigation, right? To so basically let start stop, or alter any particular like you know destination that you are going, or you want to ask basically how you want to drive the vehicle, or sometimes you want to cancel, don't know action need to be taken, for a music, or search for a place, right? um so basically those are the possible intent out of any conversation happens. So now, why so now the model is basically whenever you must be talking about. Let's think about in a real world, whenever two people are talking, all right, or you are talking, calling to a customer care agent, and you are giving him some information, right? Hey, example, you are calling to a bank, and you are in a bank, you are like, you're talking something like, hey, hello, how are you? I'm not able to log into my bank account, can you please check? Then they ask bunch of questions. Those are like, the conversation happens, but the intent out of it, the whole conversation is, if I'll tell you, that is like, unlocking your bank account, maybe it is locked, right? Or you missed. So the intent is basically finding out of the conversation, your model is finding out automatically the intent, and based on the intent, it has its own workflows, and that workflow is been triggered behind the scene. So the critical part of it is basically properly identifying the intent out of it, and based on the intent, your ML model will be basically goes through the entire history of the conversation history, and the current or the last user asked questions. Then it will find out the intent out of it, and that intent is basically passed through the for the down the system or workflow, and where your workflow will be handling the action, taking the action. So technically, this is um, basically the data I have taken. I'll just like, go, I have an input file here, and I do have a data. I'm not pretty sure like, you guys are familiar with pandas or not, but due to the time limitation, I'll not go over each of the packages that I have used here. I can share this, you can go over it, and you can just drop me if you have any questions regarding this, any of the packages why I have used it. But this is a file which is contains the like my test data. As I mentioned, when you receive a like, the main initial phase of your machine learning problem is the data. You will getting a data as the raw where you will be starting, and the first thing is basically you will be analyzing the data, right? So the analysis basically uh oh, what is happening? So basically your analysis technically will be basically load that data and see what exactly the data contains, right? So now here is here is the my data looks like. So basically the chart history, as I mentioned, right? Whenever whenever you are talking to the your car entertainment system or infotainment system, then the voice AI basically, whenever the last user, whatever the last command that you are giving, and same time the what is the history basically you are giving. So when it knows your history, that means it knows the context, right? Then it can better predict what exactly the like, your user intention is. So this is a um, data which is having the labels. When I say label, if you know this already, that means already this data set given me like, what exactly user wants to do it, right? For here I have given a history, user history, interaction history, and I have given a user last command that was been given. That means, can you suggest a nice place of Italian food? That means they want to search a Italian food nearby, like, location. That means it is a search point of interest, right? POIs. That's a it is a action. So based on this is a like, already we defined, but our solution, this level will not be there, right? So what we need to do is we will be having only the chat history, we'll having the last user utterance or language we do have, and date. And based out of this, we need to find out what exactly the level will be. Our model will be trained on this data set that has already been having the label, and we will be predicting the model that has been trained or learned it will be predicting or giving the label or the intention. It will be predict the intention out of based on the conversation. So why I picked this task, because you must have worked with numerical values, right? And you must have gone through a traditional machine learning, easy to understand numerical values, and it is pretty much easy to uh, go through the your feature engineering and find out value your or train the model. But here you don't have any numerical values. It is very much the data are unstructured data. So the question here is how you will be navigating, how if it is a unstructured data, you don't have much information about numerical data, then how you will be convert this your unstructured data to the meaningful information that can help in terms of training it, right? Now, before doing it, one thing that I want to do, as I mentioned last time, I spent ton of time in terms of doing the feature engineering before writing any of the my algorithm, or uh, deciding what should be the my algorithm to process this model or to build this model. Now, um, so for the easy thing, if you are using the Google Colab, so I would have written myself. So this is basically visualization. The data that you have right now, I have 240 data basically. So let, for example, I'll uh, just check. Um, so I do have 240 rows and the 5 columns. So that when I take save, that means I do have 240 rows and 5 columns. And out of this 5 columns, I do have a label. Label means that is the intention. And I do have the chat history and last order, user command and the language. So definitely label and language are, those are are kind of, it is a basically a categorical feature, and other things are doesn't have any. It is a free flow text. It doesn't have any specific command or features. So we need to extract the features from this. Now let's go back to this. So when you click on the view recommended plot um, in a Google Colab, it is very smart enough. It will give you a little bit of analysis automatically. So it will tell you hey, I have this number of Spanish, Korean, Japanese. These are the language, and I do have lots of English language, right? Data corpus out of 240, I do have lots of 175 English language commands, and French, German. These are basically less. So so out of this category values, definitely English value is imbalanced basically. So lots of English corpus are there or test data is there, but other language values are less. Second thing is, um, if we'll let's go back to the another plot. Um, it's called label. Labels are basically, as I mentioned, level is our goal. So how we will be predicting the machine learning model that we are training, we'll predicting what should be the intention is. So the intention, the you can see the samples that we got or the training data that we got, it has I can see the balance. It is a balanced data. Control navigation, driver manual. Driver manual is not having um, enough, doesn't have any enough samples, but it has I cannot say it doesn't have uh it is too much imbalanced. Still it is having the 20 records, and where our control navigation and no action search having 50-50 records basically. So that looks good to me. And second thing is, you can look further down, more plots basically, and you can also, using the matplotlib, you can portray more actions. But let's think about, like, the write times or the chat history and user utterance. So basically those are, write time we don't need it, because I don't see, like, that we can, if you are smart enough and you can, like, you can include that and find out like patterns out of the time, then do it. That makes sense to me. But usually it doesn't make any sense to me in terms of, right, like, including the time as a feature. I will be focusing on the chart history and the last, like, command. So this chart history and the last command, as I mentioned, like, the complexity is, it doesn't have any numerical feature. It is very much free flowing text. And your analysis is fail here. You cannot, like, do analysis. What are the analysis you will do? So basically it is a like, unstructured data. So now the challenge is right now, how I can basically uh, how I can basically uh, do a basically unstructured data to with a structured full format. Now let's go back here. So I have taken, like, two things basically my coming to my mind, right? The first thing is, uh, can I uh, take a text, a normal, like, a command that, or a any of basically uh, text command that I'm sorry voice command that I'm getting, the last voice command or the history, can I basically take that and find out what exactly the, like, the important words, you can say, like, the content. I'll go through the each of the content and find out the, like, the important words out of it, right? What are the exactly. So I also, I'll remove all the stop words. And if I'll ask you the what is the, if you'll ask, like, what is the stop word? Stop word is basically the adjectives, and like, kind of like, when you were talking about a sentence, you can read more through about the NLP, basically natural language processing, NLP, what exactly the stop word says. So those stop words basically, the which is doesn't have any uh the basic adjectives or English, in the English language, how we use those to build the sentences basically. So we need to remove those, and only keep the, like, the intended content out of it. If you will be doing it, then I can take that and I can apply some of the logic. Like, one of the logic that I can think of is the, like, term frequency and document frequency, TF and DF. TF-DF is a, I'll talk more about that. The term frequency, document frequency is basically, let's think about, um, you do have a unstructured data, and on the unstructured data, how many times a word has been occurred, right? And you will be counting it. And in an entire document, how many times the word has been occurred. So you will be basically taking those term frequency and the document frequency, and count those term frequency and document frequency values, and convert that as a numerical values. And you can use those, like, unstructured data as a numerical values. So that's how you can basically convert it. So this is a basic thing that I'm talking about, the initial start of it. So I'll be I'll clean up my text first. I'll remove, like, all the stop words, unnecessary unnecessary like, your text from the commands or chart history. Then I'll be doing converting the using the TF and DF vectorization method. I'll be converting the like, a normal unstructured data to a numerical format. That's what I have done here. So due to the time constraint, I have written already the code to showcase. So basically, here is the method that I have taken, like, process text. That text, like, take the text, and it's just lowers the text so that you will have a uniformity. Then in addition to that, like, it does, like, it removes some of the uh, your like, space and other characters it removes. Then it's clean up, basically removing all the special character and everything. then it will clean up and it will give it. It doesn't do anything much. Then second thing, what it does is, as I mentioned, like, the in the chart history, you do have like, the chart history is, if I'll go back, the chart history is kind of like contains multiple commands. The last user uh, command is single command, but the chart history contains multiple command. And from that command, what you need to do is you need to extract out, like, the commands, and join those commands, basically multiple commands, you join it and make a single sentence, and then apply necessary, basically, processing text. So that's what I have done. So I have taken, like, the history, and join all the, like, history of those data points. Then let me, if I can print it, let, for example, so df, sorry, I'll take a separate one. uh, oh, okay. Oh, later I'll just take a df, um, your, the command is the, sorry, chart history, right? I'll show you that how the chart history looks like. um, okay, so it looks like, so it truncate, basically, but the chart history technically is a multiple, like, content, basically it contains, like, array of elements. So let's go back to this. So that's what I have done. So I have made it as a single string. So the array has been converted as a single string. Now, so this is the feature engineering step here. So what I'll be doing here is, like, I'll be combining the chart history and the last user command. What I have combined it, all both of them I have combined it. So I have taken the chart history and apply, like, this method, and where I have chart history text I have created. And in the combined text, what I have done here is, basically, taken the your df, your data frame, and applied, basically, the combine both chart history text and the, basically, um, your each row, basically row by row, and combine both of them, both of columns. And finally, I have created a df column text. Let me run this, then I'll be, basically, show you how it looks like. Now, earlier df you have seen, now the new df will be look like this. So now you can see, this is a, I've taken the chat history and the last user utterance, and the chat history text, it convert, make this as a flattened structure. You can see that earlier it was a contain hello and all, this is now, it is a flattened structure. Combined text is basically combination of chat history text and the last command, basically it is combining and making a combined text. So I got, like, this is the whole uh, like, text, a combination. Now, the second part of it, basically, I sorry, once I done this, uh, the feature engineering and combine this text, the next thing is, basically, um, how I will be converting this unstructured data to a meaningful, uh, like, what I can numerical values, because machine learning doesn't understand the unstructured data, it understands only the values, numerical values, right? So we need to mindful, like, how we should convert that so that it can be meaningful. There are plenty of way, many algorithms are out of there, but let's start with a smaller one, then we'll be going on our deep learning algorithms later. But let's start with a smaller one. Before I go that, um, so one thing, you have used it, if you are first time you heard this, the label encoder. The label encoder is a, basically, is a uh, s- uh, is a predefined, like, package. If you know it already, it is a part of, like, your feature engineering process. What I'm using a sklearn, basically you can use your own level encoder. So the what is this level encoder and why I have used it? Let's think of, just notice it. The labels that we talked about, these are the labels is search POIs. Then let me go back a little bit here. These are the, like, labels, search POI, and I can see 6 labels I have. And all these 6 labels are the text labels basically. As I mentioned, machine learning will not, your system will not understand any of the text data. I need to convert that into a numerical values. And when I say numerical values, that means what I can do here is I can do a level encoder, means I can assign, okay, search POI is 1, this POI is called 1, search of POI is 2, and so on, and control navigation is 6, right? So that means instead of a text value, I'm assigning a numerical value. Similar thing. So same thing that I'm doing here. What I'm doing here is I'm taking a level encoder. Instead of writing, I'm just scikit-learn, and I'm taking the level encoder, and I'm converting into the, I'm just doing a fit transform and doing a level encoded. Now let's see how after this, what the data looks like. So this is, your analysis phase. That's how you should do. Let's see here. Now the search POI is converted as 5, number 5, and no action is converted as 2. That means instead of search POI, my I'll be I replacing with 5, 5, 5, 5. No action, I've assigned 2, 2, 2, 2. I've not done this manually, but I have taken a, a level encoder algorithm, and it does for me. And that's what you will be using it. You are not writing it unless until you need a specific algorithm and your own implementations. So now once the um your your conversion is done, still we are not reached to, converted into the text data. Now here what I can do here, I'm doing is basically I'm splitting the data. It is a standard practice. So basically, uh so as I mentioned, um part of this whole data set that we have done so far, we do have two part basically. One is basically the label which is we are predicting, but training data idea has been already given, but we are, the solution that building, or the model that we are building, we are predicting this level. Now when you will be training, uh, you will be basically, what you will be taking here is you will be taking this axis. Basically x is basically your combined text. This is your combined text, and y is basically you are taking the label encode. uh, that's what your intention is. Now what you will be doing here is you are creating a training test, your split basically. And the train test split is a part of, sklearn. You can do it yourself also, but I have taken, your sklearn, and I have passed, the text split basically. So I have given, test split means 80% will be goes to the training, and 20% go to the your test. So let's run this. I'll also show you how the data looks like. Let on the X train, how it will look like. So on the X train, you can see it is only the combined text, right? Nothing more. And the, your Y train, it will be basically um, only the level encoded, the values, corresponding values. Similar thing, X text, only the your combined text, and Y test will be uh, level values. So this is a concept, basically ML concept. I'm not pretty sure if you're aware about it. If you're not, definitely read through it. Why I have split it, due to the time constraint, I cannot go to the very basic of it, basic machine learning concept. Why I have split it, and what is the requirement of it. But let's move forward. Now the challenge here is still my training X train is basically it is having a uh, so unstructured data. So how I will convert this, as I mentioned, I'll be going out. a method is called TFDF, basically, like Tom factors and the document factor. So what is this Tom factor document factor? I have already explained. Like let's for example the human request information about local something, right? So this how will be like extracting out how many times a particular word has been occurred, and what is the on an entire document, what is the value of it, and we'll be converting this as a numerical value. This is very basic of it. And I'll be removing all the stop words, and I'll be taking maximum features is 500, that 5000. That means I'll be taking maximum features on a particular uh, complete unstructured data, maximum 5000 words I will keep it. Then I'll be basically vectorizing both training and the test split, and I'll be converting it. Let's run it. Then I will be saying basically now you have seen already the X training was the combined text. Now I'm doing a TFTF and how it will look like. Let now I'll be doing a extend TFTF. Let's see how the value converted. Right. Uh, so basically it is basically it's a sparse, it is a plotting values. Basically it will not be able to show here, but technically it is a convert your this whole set of uh, your text into a vector data. Basically instead of a text it will convert it in a numerical vector, and it will be having your each of the numerical values when it is occurred. It will create a vector out of it, and so that you will not have any unstructured data. It will be now at a structured format. Now next step is basically uh, now my feature engineering is done. I converted all of my features. I have only one feature here, and converted this as a like numerical values, and now my data is ready for training. I'm not doing much here. So once it is ready, then as I mentioned, we are going at a very simple solution right at this moment. So it is a multi-classification problem here. So multi-classification problem means I'll giving a text, whole bunch of text, and my machine learning model will be like uh, automatically predicting what exactly the intention out of it, right? I'll give you a whole text, and it will predicting hey, I need to search a location, or I need to do any action in terms of stop any location already running, and or navigation is already running, or and take any action in terms of any car operations basically, right? So I need to my machine learning model will need to predict based on this data. So now come back. So I have taken a logistic regression. Logistic regression, if you're not aware about it, so it's algorithm that can it can help you to multi-class problem. Basically it will take the your data, and it will tell you which class it belongs to based on your training. So that means I've select it is a very much traditional algorithm, logistic regression. The so you can basically read it's a classifier algorithm, you can read through it. And the class weights basically I have given is a balance in terms of whenever you do have a multi-class problem, and you can basically uh let me open it so that you can just I can give you a quick idea. Basically you can go to the sklearn, and you can read the class weights, basically what is the all these class weights. So you can give basically each of the class level. I do have multiple labels. Basically these are the class labels. Basically sorry, these are the class labels. um, these are the class levels. Search aware and search py is a class level, but technically we have converted this as a search py is as a 5. That means we need to provide 5, what is the weight basically. So if you want to particularly decide how many weights for when you will train the model, then you can manually select it, or you can give basically as balanced. Then automatically this is the algorithm that will be used to decide the weights for each of the models. So I have taken as a balanced, and it will be balanced out each of the occurrence of my weights, sorry, classes, and it will assign that wait basically. Max iteration is basically how many the iterations that is required for the model to train and where it will be converged basically. So you can read through all this, like the options that you can see on the scikit-learn. You can search and you can learn more about this. Now, coming back to this, I this is my model, and I'm training this on model, passing my x train is for training, and y train is basically the level, and I pass through this, and I train my model. And I am not passing it is a standard machine learning concept why I'm training on x train or why I'm not y train, sorry, y train, because you can read through it basically. Sorry, X train and X test basically. So now, if I'll be doing a training, it's a pretty simple model. So it has already converged, and I have to have a very less data as well. So only 240 rows. So it's pretty simple to converge, and immediately it got converged. If your data size is pretty big, then definitely it will take more. And if your data size is have more multiple um your features, then it will take more time. Now my model is there. My
Excuse me,
model.
sir.
So yeah,
Yeah, it's 40 minutes, so we have three questions to take. So is the time allowed? So what do you think? How we can proceed further?
that's fine. We can go till the hour basically. Till hour. I have till 15 minute I can extend. So let me complete this. Then we can go back to the question.
Cool. Thank you.
Cool. So awesome. Let's come back. We train the model, then we'll be evaluating the model, whether the model that we trained, it will be how it is behaving. So I can pass out the test data. Basically, I train on the training data, then I pass out the test data, which has the model has not seen it, and it will tell you will see it will predict automatically, it will predict based on the on-send data. Then from that on-send data I'll be find out my accuracy and the FN score, and which will be telling hey, how the best my model is. Let's quickly do it. And after I have done that validation, then if I'm printing, oh, my accuracy looks 0.58 and 54, it is not good, great. But we can definitely, there is a lots of scope to improve it. So if the accuracy is 0.58, it's not acceptable, I can say practically. So it depends on prompt to prompt, it depends on which kind of problem you are solving. So we need to put more focus on terms of improving the model, basically what how we can add. Now let's test it. Now my model is ready. I done the accuracy test, but although it is not great, but let try to find out uh test it basically. So now I'm just passing a sentence, hey, can you suggest good Italian restaurant nearby, right? Or some good Indian restaurant nearby, something I'm passing. And this sentence I have, my model has not seen it, and my task is I'll pass this, and my model need to predict what exactly I'm looking for. It's I've written a bunch of I loaded the model, I passed the uh, I have used the model, I've done the prediction, and I passed the simple sentence. And the sentence I cannot pass as it is. I need to convert that, pre-process the text similar, this is called reverse basically. Whatever the way you have done to train it, the reverse thing you will do when you will be testing it. You pass the raw text, you convert that into the process it, then you vectorize it, that you find out the TF-DF, then you pass that TF-DF into the model.predict, and you pass that TF-DF, and your model will be predict the value, and it will be, you will be printing it, the value. This is the actual value that you will get. Now let's run it. Then how exactly it is done. Okay, awesome. It is behaving good in terms of search POI. So basically Indian restaurant, that means this is kind of a search command. So it's understand the context basically. Let for example, I'll doing something hey, start my car engine, something I'll be doing let. So it's kind of telling my no action or something, um, cancel my uh, navigation, something. Okay, control navigation. Think about it. So now my model has been trained, and it will giving you like, uh, so automatically this has like, randomly I'm putting the text and I'm giving like, voice command. Now we have only like, 15 minutes. I'll quickly go over like, a advanced version of it. This is very much like, this is like, just a learning purpose. But actual, when you will be doing in a real world, this will not work this way. You should not like, your work will not be done. So what we usually do is, this model that we trained is a very much like, a is a very simple model. So what do we with the same thing that we have done, the same like, data. The only thing is that I'll be applying the deep learning basically. So what we'll be doing is, we will be, as you mentioned, like, there are multiple language basically. The how I'll be converting embedding basically, instead of like, doing a vectorization, I'll be converting a multilingual embeddings, right? It is a transformer based, sentence transformer based basically deep learning algorithm, which will be convert like, my language into the multilingual uh, uh, transformer. Then in the model that I have used is called logistic regression. Instead of logistic regression, I'll be creating doing a deep learning transformer model is called a digital board. A digital board basically is a multilingual transformer model, which will be more efficient, and it has like, more, it will be more accurate in terms of like, your predictions. Then I have done the like, uh, I include the language as a feature, one hot encoding I'll do. Then based on the language specific pattern I have done. And in terms of like, intent related keyword, reducing the noise, token limitation, all these things that I have done part of like, thing. Due to the time limitation, I'll quickly go over it. Like, I'll show you the important part of it. Same thing that I have done, pre-process the text, summarization of the chart history. But here I have taken like, the top three chart history, and only the like, human chart history could be like, multiple basically, when you will be talking and when the voice will be giving a command, system also giving a command. I'm not considering the system commands, basically only the human command. That's why I've created like, only the human. And I've taken like, top three, last last three commands basically. I'm not taking the whole set of commands basically, it can bias the system. So that's how I've taken the like, last three commands. Then I'm converting like, chat history, combining the text, that similar thing I'm doing. And I've combined the text. Then I've done the like, language as a feature, and similar like, one hot encoding that I've applied. uh, there I have used the level encoding. Here I'm using the one hot encoding. And you can read through like, what is the difference between the level encoding and one hot encoding for converting a feature, basically like, multi-class features basically. Then I have added the language as a feature. Then level encoder for the normal level basically same similar. Then I'll be test and split. Then here is the most important part, the changes that I have done is called like, I've used a transformer model. Instead of here I was using a tfdf basically to convert it, uh, like, tfdf vectorization model to convert that into a numerical value. Instead of that, I have used a sentence transformer basically, right? So that transformer will be creating embedding. Instead of creating a vector, you will be creating embedding. And you can search about like, what is the difference between vector and embeddings, and like, embeddings and the vectors basically, with the difference, how the transformer does better at deep learning. So you can read through it. And I have combined it, similar test train. Then I can basically, here I have done a little bit of like, tokenization. Instead of doing a plain text, basically I've done the tokenization, and I've added like, more um sorry so I've added like, more feature engineering task that I have done. And I have used the distill birth to do the tokenization of it. And this will be tokenization basically, instead of doing a tftf or normal text, I've done like, convert, how I convert like, your entire text into the more numerical rich features that I have done. So then I've done the train test data set. Then I have like, the weight to balance to imbalance data, how I have handled the imbalanced data, basically the class imbalancing I have done. Then there is a weight trainer basically. Instead of like, going for a normal weight, basically here class weight is balanced, is a very much like, standard one. Here I have created a weighted trainer basically that would be more efficient to, like, if you have an imbalanced data, then how you can handle it, right? So that I have done it. Then I have taken, like, training parameters here. I've taken all this hyperparameter setup I have done for a deep learning. Then I have created a weighted trainer. I've trained model I have created, and that model I'm training it here. Then I'm evaluating that, and this is definitely the same thing it will do. It will create a model, and that model will be basically is a deep learning model instead of, like, a like, a standard your regression model, basically logistic regression. It is a deep learning model now, and the same thing it will does. And so it has basically the right now the accuracy and the FN score is, like, less than this 0.47, 0.45. You'll see, like, this accuracy is basically 0.58. But technically, like, I can do more in terms of, like, why the accuracy is less, and I can more deep dive in terms of, like, your feature engineering, and I can improve it. So that's that's pretty much like the advanced version looks like. And a real world, this kind of, like, the deep learning models that you will be using to work on the feature engineering, to basically work on the unstructured data. Basically, it the structured data, if you have it, is pretty much easy, but unstructured data you need to have lots of complexity in terms of dealing with it. So I'll stop here and I'll go back to your questions. I'll stop sharing my screen. Let me, yeah, sure. Yeah, over to you, Manik.
Okay, wonderful. That's amazing, sir. Now we can cover three questions. I guess we have three questions. And yeah, Vanshika, you can cover the questions in the meantime.
So, sir, the first question is from Shreya. She's asking how to take ML projects to production smoothly and what can be the strategies or resources you would suggest on pipelines.
Yeah, very good question. So, smoothly, it's a very, like, big term. You can say it, like, the real time production, like, when we are working here, working our there are different, like, different teams that we work together. Okay, it's not a single team. Mostly work with the big company, like, small. If you're working on a small small company or startup company, you may be, like, working end to end. All right, you are working on, like, creating the model, analyzing the model, data engineering. Then you will be doing a, like, ML ops, everything you will be doing, and infrastructure you are taking, and you once in goes to the production, then you will be doing observability, everything you will be doing, right? That you will be lucky, basically you will do it. But in a real world, that doesn't work. Basically, when you will go to a big org, then you will be having a different team that works each of the component. For example, the data engineering, the data part, basically the data engineering takes care of it. Last call I have explained it already. So you get the data, then as a data scientist or a machine learning engineer, you will be doing analysis, and you will be making basically ready your model. Then that model, once you see the model, like, accuracy is good, then you send that, like, your um, deliverables to the MLOps team. MLOps team is work on the productionizing those model, basically taking care of, like, entire pipeline, automating the everything. Then from there, the MLOps team will be interacting with the infrastructure team. Infrastructure team is mostly, like, who provisions your, like, servers. You're running on a cloud, Amazon cloud, or sorry, AWS cloud. Then, so on the cloud, you do have, like, once your model goes to that, then what is the, like, resources that you record, how you can make it, like, containerization, basically using the Kubernetes and Docker, all the script that you need to write. Part of, like, it comes to, like, as MLOps. Also, sometimes, like, the infrastructure takes care of it. So it's a combination of, like, multiple teams that makes the thing smoothly. And yeah, so next questions.
Okay, sir. Thank you. I guess, Shreya, now you are clear with the concept. Now we are moving towards our next question from Anshika Singh. She's asking basic meaning of CI/CD pipeline and how it's achieved and do.
They mentioned something. Okay, CI/CD pipeline. Okay. CI/CD pipeline on the machine learning world, like C word that is called your MLOps. Okay, so the CI/CD is a bigger concept. You can think about like I'll talk about like only the MLOps world basically. So um, in MLOps, you do have two section basically. I can say three section technically. The first section is basically the experimentation environment. Experimentation environment is basically you are giving a how you will automate your data scientist, right? So how basically they can easily access the data, they can do the experimentation, they can track like let for example right now I have trained a model and I have used some hyperparameters and I have like out of that hyperparameter I have created some like then I got a evaluation metrics and I when I do some changes then I will be doing another hyperparameter or changing some code and getting another evaluation. Let maybe the first evaluation is better, then second evaluation is low bad, then I want to revert back to the second one. So that is basically called as your experimentation environment. So experimentation environment basically you need to facilitate as a MLOps engineer how exactly the experimentation environment will be more like what I can say. You can track out each of your experiments easily. It will be automatically save your model into the model registry and also track like your each of your technically each of your your hyperparameters. So that is one portion. Second portion is basically once the model has been ready then you will be productionizing the model, right? Before productionizing you will be having a beta environment or your dev environment, right? So that is basically you will be how you will be bringing your model that has been trained by a data scientist or ML engineer from your like a model registry to a setup like in a offline inferencing or a batch inferencing or online inferencing. How we'll be creating like training that model already. If it is training already like taking that model into the model directly to the productionizing or retraining it, and or you will be basically doing a basically uh, you know the entire automation of your infrastructure deployment that is required for based on the requirement of whether it is offline online or a multimodal deployment that need to happen. So that is the second phase. Third phase is once it is goes to the model then to production from the dev and QA and then prod. Then third is basically model monitoring. That is your once your model is run the production, then it is called model monitoring. That also done by the CI/CD pipeline, and that is part of like your MLOps. And very critical, that is your observability and the model monitoring. How exactly my model is behaving on the like real world. That is called your model drift, data drift checks. Basically, you are writing a CI/CD pipeline. So that is basically the third portion of it. So I can say that's the life cycle of a entire model. Now we can take another question.
There's another question from there's one more question from Anshika. She's asking about some real world problems, project ideas. To start, in previously, she has made a diabetic prediction system and how more ideas based on real world problems.
Okay, it's a very interesting question. I always told this already. I have told you this. Um, go to basically all the hackathons, basically, right? Hackathon that is happening. That's a real world problems. Every company keeping a like bounty amount, like hey, if you we have a problem and you solve it, right? So you join to that like hackathon group, and every day there are a new hackathon problem that is like new real world problem by the big companies, including Amazon, Facebook, Google. Every company is like they publish like real world problem they are facing. They're like they're facing and they're not able to solve it, or they're like open for the new ideas how the other people solve it, right? That's why they publish it. And in addition to that, they also provide you like infrastructure, and sometimes they provide you like the winning amount as well. So it is a very much like good starting point where you will be basically practically you will be having a real world problem that the companies are trying to solve. Not only you will be working on it, you will be learn about it, right? Instead of like doing a just a theoretical problem and a test like data set and exploring it, learning it, that doesn't lead you anywhere. That's a starting point to learn, but actual implementation, when you actually really want to learn, then go and join the hackathon groups basically, and make your hand dirty. And even though your contribution the first hackathon didn't go went well, you didn't able to understand the problem, that doesn't make any like that doesn't like you don't have to de-asset medically. You can basically keep on focusing, you can try the another one, and that will be helping you to improve and learn more from the like real world prompts basically. So that's the best way to learn. Yeah, any other questions?
Wonderful. I guess all the questions are
So we
covered.
have
So
received
mostly.
one more doubt.
Okay, we have one more doubt. Yeah, Vanshika. I guess your network is not stable.
There's one more
I'll take care.
doubt left. As AMS's exam, the MCQs will be asked from, so we can revise and prepare accordingly.
Okay, that question would be taken care of in the group. I guess that question is not
Like
related
she
to
is
the
asking
topic.
about the topics the MCQs will be asked from.
Okay.
Is my voice audible, Vanshika?
Yes, we're audible.
I guess there's network issues on your end. I'll take it from here. I guess all the questions have been answered. Thank you so much, Suvindu sir, for
It's a
sharing
pleasure.
all the insights. Like in the two sessions, you have shared most of the complex topics, and this one is pretty practical. And for taking all the questions. And it's amazing to have you. Anything that you want to say in the closing keynotes?
Yeah, so I'm my LinkedIn inbox is always like available. Just ping me if you need any further clarification or any guidance. All right, I'm happy to do that. And like I'll share all the resources that I have already like presented on this two session to Manik, and Manik can share with you guys. And yeah, I'm always available to guide you, and it is the best. Like it is a great my pleasure to be here. Right. Yeah.
Okay, thank you so much, everyone who have watched the session. And yes, keep exploring, be curious, because ML is all about learning, helping others, and just getting deeper and deeper because it's the like vast ocean. And these are only the buckets that you're learning, and there's a lot to learn. So yes, thank you so much for joining, and thank you so much, sir, for yeah,
I just want to add a last statement here, although it is like not relevant here, but like for your career aspect basically. So you must be like this is my understanding basically, since I'm working on machine learning and things. But if I'll be you, and the way the world is moving the fast, and it is all the world, all the tech companies, all the tech that are in the market are moving towards the AI, and the AI is the next like the like skills that everybody should be having. ML is the like skills everybody should have it. You are on a right track, right? It's a little difficult to initially to start with like a normal software engineering job than a machine learning job. It's a really little difficult to push it, but if you push right now, then your career will be really growing career, and you will not have any obstacle in future, because you must be heard like many jobs are going because of the AI, and that's true. It's not just someone is making off. It's true, many jobs are going and it will go. And only thing that you can make yourself forefront is by learning the right set of skills, and the skill that is on demand is called machine learning. And you are on the right track, stay on the track, learn. Okay, that's my advice.
wonderful, the best keynote that we could ever have. Nice. So now we can end the stream. Thank you so much, Suvinder
Thank
sir,
you.
and thank you so much, everyone. Okay. Further, we'll be having a lot of sessions. You can join that. Uh, we've got